Hi, everybody. I'm Miguel, and I'm going to talk about the impact of privacy protection measures on online advertising markets. In particular, I'm going to focus on the upcoming block of third-party cookies by Chrome browser. This is a joint work with Shunto, Kei, and Matt from Caltech. Internet companies collect a vast amount of sensitive information from users, for instance, browsing behavior, identification information, payments. These data are employed for different purposes, for instance, to recommend products, to personalize online experience, or to target users with advertisements. The collection of information about users triggers a public debate about online privacy protection. Centering this debate is the role of third-party cookies, which are used to track online user behavior across different domains and implement targeted ads. In response to these concerns, many governments have implemented privacy regulations to restrict the collection of consumer information. For instance, we have GDPR in Europe or CCPA in California. In addition, internet firms have also tailored their products to meet the rising privacy concerns of their users. For instance, Safari and Firefox have blocked third-party cookies by default for several years now. In a highly anticipated move, Google has announced its plan to block all third-party cookies by default for users browsing via Chrome. Chrome is the most popular web browser right now. This move has been delayed several times, and now it's scheduled to happen in 2024. Although the main intent of these policies is to protect internet users, this move will impact advertisers' ability to target consumers effectively. As online ads lose their value, web publishers' advertising revenue may decrease. Right? Moreover, blocking third-party cookies may give some firms an information advantage. For instance, Yahoo and Google, they can still get a lot of information from their users using first-party data, right? So Google's plan to block third-party cookies may give Google an information advantage over other players in the online ad market. Such concerns have to call the attention of antitrust authorities. We have several examples, for instance, in UK or US. So in this paper, we are going to evaluate the impact of removing third-party cookies from Chrome in the online ad market. We are going to use data from Yahoo Ad Exchange, and we are going to use a structural model. That will help us to conduct some welfare analysis and counterfactuals. In particular, today I'm going to talk about 3 counterfactors. The first one is Chrome blocking third-party cookies. The second counterfactual is the case where we allow one bidder to retain information about users while the rest of the bidders lost access to that information. And in the third counterfactual, we are going to explore alternative targeting technologies in line with the tools developed by Google under the privacy sandbox. As I mentioned before, we use bid-level data from Yahoo Ad Exchange. We focus on banner display ads that they use a first price auction mechanism to allocate and price ads. And yes, as an institutional comment, the advertisers, they don't bid directly on Yahoo Ad Exchange. What they do basically is they use demand-side platforms that there are third-party companies that they bid on behalf of the advertiser clients. We use 1 week of data from 2022, and we focus on the US. And the sample data contains information about the most important properties of Yahoo. That includes homepage, finance, Yahoo Mails, etc. The figure shows the geographical distribution of our sample. Basically, as I mentioned before, we focus on the US. And the table shows some summary statistics of key variables. We use, our sample contains 1.2 million auctions and 8.8 million bids from DSPs, that are the bidders. So we can see the variables, the bid submitted by the bidders, the number of bidders participating in the auctions, the winning bid, that because we are dealing with a first price auction mechanism that corresponds to the publisher revenue, and also the percentage of impressions with cookie matching. For confidentiality reasons, we normalize the bids to have a mean equal to $1. We also use additional features like the site names, user characteristics that includes gender, age, location, and other variables, device ID, browser identifier, and DSP identifiers. As I mentioned before, we use Yahoo data, so we make the assumption that the other bidders observe similar information. Because we focus on the impact of blocking third-party cookie on Chrome, it's interesting to compare winning bid and entry probability across different browsers. Here we have Chrome, Edge, Firefox, Safari, and other browsers. And then we show the winning bid, entry probability for impressions with cookie and impressions without cookie. Okay, so for instance, if we look at the bid and Chrome browser, we see that the average bid of impressions with cookie is $1.07, while the average bid of impressions without cookie is around 83 cents. So if we see the winning bid, we can see that Yahoo is able to monetize much better impressions with cookie than without cookie. Right? So impressions with cookie winning bid is around $2.63, while the winning bid of impressions coming from impressions without cookie is around $1.31. So again, if we look at the entry probability, we have similar impact, right? So we see higher entry on impressions with cookie, around 29%, while impressions without cookies, the entry is much lower. Another comment here is we can compare impressions without cookie coming from Chrome and other browsers like Firefox and Safari, and we see that the numbers are pretty similar. So, for instance, the average bid on Chrome is 83 cents, while the average bid of impressions without cookie in Firefox and Safari is around 71 cents and 79 cents, respectively. What we are going to do in our counterfactual is we are going to assume that all Chrome impressions become cookieless and see what are the impact of this counterfactual. Some comments about the model. So we use an independent private value first price auction with entry. We have 36 potential bidders. We denote the auction characteristics as a capital X. And when an impression opportunity arrives, the bidder I gets a valuation for that impression that comes from capital F distribution of valuations. We model the problem as a two-stage problem where we have first the entry in the auction, let's denote that as a P, and then the base Nash equilibrium bidding strategy is denoted as capital B that maps the valuation of the impression opportunity with the bid submitted by the bidder. Here we have the bidder expected profit. So the profit that the bidder I gets from impression T is equal to the difference between the valuation of this opportunity minus the submitted bid by the bidder times the probability that the submitted bid is greater than any other competed bid from other bidders. Under some assumptions, we can rewrite this expression as in terms of probability of entry, P, and valuation CDF, capital F. And we can also rewrite this expression in terms of equilibrium bid CDF. Some comments about the estimation approach. In step number 1, we estimate the entry probability P. And step number 2, we use the first order conditions of the profit function to recover the valuations from several bids. We use the same approach as Gerb, Perrin, and Wong. And then we can estimate the valuation distributions, capital F, and the base, and get the base Nash equilibrium bidding strategy, capital B. We introduce some bidder heterogeneity. In particular, we assume 3 types of bidders: large, medium, and small. Here we have the estimated valuation and bidding strategy for large DSPs. On the left-hand side, we have the valuation CDF, and then the right-hand side, we have the bid strategy for cookie impressions and no cookie impressions, right? So we can see that the large bidders value more, on average, the impressions with cookie than impressions without cookie. If we look at the bid strategy, For a single valuation, we can see that the bid submitted for impressions with cookies much larger than the bid submitted for impressions without cookie, right? Obviously, auctions are more competitive, leading to higher equilibrium bids. So, given the estimated valuations, we are going to simulate several counterfactuals. In this case, we have two counterfactors, what we call symmetric band and asymmetric band. In the symmetric band, we simulate the third-party cookie band affecting all bidders. So basically, all Chrome impressions are marked as a cookieless. And in the asymmetric band, we simulate the case where one bidder still retains the capacity to observe impression information about the users. Okay, this is the case where we assume that there is a bidder with information advantage. Here are the results of the counterfactual. We show the bid, the number of bidders and winning bid for the different cases. The status quo is the benchmark. The symmetric band is the case where all DSPs or bidders are impacted by the third-party cookie ban. And the asymmetric case is where we have one bidder that has informational advantage and retains the capacity to observe information about the users for a particular impression. So if we compare the impact of the symmetric band and the asymmetric band, overall, basically, the results are very similar in terms of the average bid, the number of bidders, and winning bid. But probably the most interesting thing here is that we can see that the impact of blocking third-party cookies is pretty large. So if we look at the publisher's revenue, that corresponds to the winning bid, the drop in revenue is pretty significant. It's more than 40%. So if we look at the counterfactual by type of bidder, as I mentioned before, we have large, medium, and small bidders, and then we have one bidder that has the capacity to observe user information in the asymmetric band. And we can also see in terms of winning frequency and surplus, right? So if we focus on the advantage, the advantage bidder, that's the one who retains information, the capacity to observe user information for a particular impression, we see that banning third-party cookies on the rest of the DSPs has a big impact. So if we look at the status quo winning frequency, it's for the advantage bidder, the winning frequency is around 7.9%, while when we block third-party cookies on the rest of the bidders, the advantage bidder wins 18% of the time. Okay? That translates into also an improvement on surplus for that particular advantage bidder from $1,600 in the benchmark to $3,000 in the asymmetric band. While the advantage bidder benefits from blocking third-party cookies on the rest of the DSPs, the rest of the bidders are impacted negatively. In particular, they win fewer auctions and get lower surplus. The last counterfactual is considering the case where we allow an alternative targeting technology in line with the tools developed by Google under the privacy sandbox. The spirit here is to generate a group of users with similar interests, giving advertisers a way to target users without exposing individual details. In this counterfactual, we replace Chrome users' behavioral characteristics by the average characteristics for each website. For instance, imagine a female visiting Yahoo Finance. So in this counterfactual, the bidders are not going to observe the gender of the user, but they will know the probability that a user is female or male, right? In the case of the asymmetric band, we still allow one particular bidder to observe that that user is female, right? And this happens not only with gender, but the other demographic characteristics of the user. So here are the results. So if we look at the advantage bidder, we see that the bidder still benefits from blocking third-party cookies, but less than in the case without any alternative, right? So now the winning frequency for the advantage bidder increases from 7.9% to 12%, while in the case without any alternative, the advantage bidder winning frequency increases to 18%, right? The same with the surplus. So, with the alternative targeting technology, the bidder surplus increases from $1,600 to $2,200, while in the case without any alternative, the advantage bidder surplus increased from $1,600 to $3,000, right? The same for the large, medium, and small bidders. They win less often and small impact on terms of surplus, but the introduction of alternative targeting technology ameliorate the negative impact we have if we don't introduce any alternative. Just to conclude, so privacy policies have an impact on online ad markets. The Chrome ban on third-party cookies can have a very substantial impact. As I showed you before, we estimate a 40% reduction in publishers' revenue. Alternative targeting technology can mitigate the impact of this of banning third-party cookies on Chrome. And one concerning part is the ability of having one bidder with informational advantage that may justify the antitrust concerns of authorities to Google's plans to eliminate third-party cookies. Thank you.